So, today we're going to be talking about ionization energy. My name is Dr. Kim. One of the first things we need is a definition of what ionization energy actually is. Well, ionization energy, which is often abbreviated with an IE, is the energy needed to remove an outer electron from an atom. So in other words, it's how much energy it takes to go up to an atom and grab an electron and take it away. Now some atoms hold on to their outer electrons real tight, so it's really hard to pull that electron away. They fight. It's really hard. Other electrons practically give their electrons away. You go up, grab the electron, whoo! It's really easy to pull it away, so the energy is rather low. So let's think about the trend. Ionization energy is going to increase, either up or down in the table. So let's look at the periodic table. As we go up versus down, we've learned that we're getting larger as we go down, and we're smaller as we're at the top. Now, let's think about this in terms of size. If we have an atom, and we have our protons in the middle, and here's our first level. And if that's the outer electron, goodness, it's awfully close to the positive protons. In order to pull that away, I think that's going to be pretty hard because it's so close to the protons and the negative charge of the electrons. There's a lot of attraction here. So this is going to be hard to pull away. It's going to equal a high ionization energy because it's so small. The electron's so close. It's going to hold on to it tightly. It's going to be hard to pull away. Now, what about big fat atom? And the outer electron's way out here. And it's negatively charged. But it's a lot farther away from the nucleus. How tight is that electron held? Well, it's kind of far away from the nucleus. You know, maybe this is the 5th or the 6th level. So it's going to be, frankly, easier to pull away because it's so far from that positive nucleus with all the protons. So this is relatively easy to pull away. So this is going to have a low ionization energy. So smaller atoms are higher, larger atoms are lower. So again, the trend here, we're going to increase as we go up. The energy is going to get larger and larger and larger and larger as we go up the table, as we go up towards the smaller atoms. High ionization energy up here, low ionization energy down here with our big fat atoms. Okay, so that we're going to increase as we go up. Now, what about the left versus the right side of the periodic table? Well, what kind of elements are over here? What is this section over here called? With the exception of hydrogen. These are metals, that's correct. And what's over here? Nonmetals. So we're kind of looking at the difference between metals and the nonmetals. Well, what do metals want to do? And maybe you haven't learned this yet. But metals actually want to lose electrons. This helps them to become like a noble gas. Okay, so they don't become noble gases, they become like a noble gas in that they have the same number of outer electrons. In order to do that, they must lose electrons. Okay, they tend to lose 1, 2, maybe 3 electrons, and that helps them to become like a noble gas in that they have the same number of outer electrons, which we'll talk a lot about when we do electron configuration. But metals want to lose electrons. So are they holding on to them tightly or loosely? So they hold their outer electrons. If they want to lose them, they're not holding on very tight. So they hold their outer electrons loosely. Does that make it easy or hard to remove them? You're correct if you said easy. easy to remove. So is that a low or a high ionization energy? You're correct if you said low. Low ionization energy because they're easy to remove. Well, what do nonmetals want to do? Maybe you know, maybe you haven't heard yet. Their goal in life. What is their goal in life? What do they want to do? Well, nonmetals actually want to gain electrons so that they can become like a noble gas. So they want more electrons. Non-metals walk around going, gimme, 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 gimme. Give me some electrons. So how are they holding on to their outer electrons? Yeah, they're holding on to them tight. Okay, they're holding on to their electrons tight because they want even more electrons so they can be like a noble gas and have the same number of outer electrons as a noble gas. So they're holding on pretty tight. So is that going to make it easy or hard to remove the electron that's held tight? You're correct. It is hard to remove. So does that take a lot of energy? Sure does. It's a very high ionization energy for those nonmetals. All right, so metals have low ionization energy. Nonmetals have high ionization energy. So here's the metals that are low. And as we go across, we're getting higher, 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 higher. So the trend, back to our trend, is that we're going to increase as we go across. So ionization energy is the energy needed to remove an outer electron from an atom. Small atoms hold their electrons tighter, so they have higher ionization energies. Up here, the small ones. Big fat atoms hold on looser, so it's a lot easier to take them away. And as far as metals versus nonmetals go, metals have a lower ionization energy because they hold their electrons loose because they want to lose some. Nonmetals hold their outer electrons tight. It's hard to remove them. High ionization energy. Here's actually a graph of the periodic table showing ionization energy. Here's hydrogen. Here's helium. Look how far up we went. Very high ionization for helium. Then we go down to lithium. And as we go across, we increase to neon. And then we go down for sodium. And as we go across, we increase to argon. And then we go down for potassium. And as we go across, there's a few exceptions, but we go up to krypton. Then we go down for rubidium. Then as we go across, we go up to xenon. So if you look at these low points, lithium, sodium, potassium, rubidium, cesium, these low points are alkali metals. Okay, so the metals had the low ionization energy because they want to lose one electron actually. So the alkali metals want to lose an electron. So that was pretty low. And if we look at the high point, helium, neon, argon, krypton, xenon, radon, those are our noble gases. They don't want to lose any electrons at all. They're already noble gases, so they're already perfect. So they definitely don't want to lose any electrons. So we increased from low ionization energy to high ionization energy as we move across the table. And we can see that in this graph of the periodic table. All right, so I hope that explains ionization energy a little bit better. You need to understand the trend. Remember, small atoms hold their electrons tight, so do the nonmetals, and then big fat atoms and metals hold on a lot looser. All right, thanks a lot. Good luck.